All right, let's have a look at these functions. First of all, if I actually look at b first, you know what y equals x squared minus 9 looks like. Sorry, bad drawing. So it's just a parabola that's gone down 9 places. So we already know that if we do the horizontal line test, this inverse is not a function. We would have to restrict it to x is greater or equal to 0 or x is less than or equal to 0 in order to get an inverse function. All right, so now let's ignore that one and have a look at the first one. Now, if I swap my y's and x's, so f of x was y, so x equals 1 minus y and 1 plus y. A lot of people have trouble with this one. So the trick here is we multiply both sides by 1 plus y to get rid of that denominator, and you get x plus xy equals 1 minus y, and that's where people get stuck. Remember, we want y by itself. We want to isolate y. So what we do is put all the y's on one side and everything else on the other side, and we factorize by y because we want y by itself. And you'll see we get 1 minus x on 1 plus x. Have a look. That's pretty interesting because look at that. So you can see there that f of x is going to give you the exact same thing as the inverse function. All right, so if we, for example, put something in like f of, let's put f of 1 in. Well, let's go f of 3. So if I put f of 3 in, what would I get? I'd get 1 minus 3 and 1 plus 3, so I would get a negative half. And then if I put negative a half in the inverse function, so in the inverse function I'm doing 1 minus minus a half and 1 plus minus a half. So I'm getting 3 on 2 at the top, and I'm getting a half on the bottom, which is 3 on 2. Is that right? Sorry, which is 3 on 1, which equals 3. And you can see we get back to the original. So I'm really doing, you know, f of f. So f of x is the same as f of the inverse function of x in this case, because the inverse function is the same as the function. So that's why it's kind of interesting.